Basically it's a transformer production project. We are protecting the transformer by overloading and decrease in oil level, and also the increase in temperature inside the transformer windings. So it's a normal load. It's a normal load, and we're using power line communication for communicating between the load side and also the utility. Now when I overload this guy, is a unit 2. When I overload this guy, the message will pop out here. Unit 2 is overloaded, and it will be sent through power line communication to the utility center, and the extra tariff may be for this guy. Every year, because of transformer damage, 4,400 crores will be lost every year in Karnataka. Only it's 400 crores will be lost, so that we can stop that one by using this system. And it's a smart meter. Actually, this all thing will be incorporated into single meter, and it's called a smart meter. And also now the oil level is normal, floor sensor oil level is normal. If it will be decreased, the second will be off, because we can't take a big transformer and we can show. So we are using this small demo piece and we are showing, and its second will be off, so that nobody will get supply. Oil level, floor sensor. We are using floor sensor for oil level. And also using LM35 for temperature sensor. LM35, its precision is for 0.5 degrees Celsius, and actually we until 40 degree, 50 degree we put for ambient degree. So we can't show it because we are not having any solder gun and all. So above 50 degree, if it increases, means temperature will be down. I'll show you. See if both unit 2 will be overloaded, and it will be sent. Particular consumer will be tripped, but this guy will not be affected. That's the main thing, because the tariff will be put for this guy only, who is overloading, only for that guy.
Good morning everyone. Like as you have seen in your daily life, you have seen many grass cutters, I mean lawn mowers. What it's like, they use the fuel over there, like as the source for power generation of for the power of the motor. So what we have done here is, we have built a project. The name is solar power grass cutter cum floor cleaner. Like here we are using solar power as a source. By using solar power, we are storing the current in these two batteries, 6 volt, that's a 12 volt, and that we are using as for the tree purpose, like for cutting the grass over here in front side, for cleaning purpose in the back side by using the scrubbers, and for sprinkling the water by using the water pump. These are tanks where we used to store the water, and it is like this is very eco-friendly and no pollution in this thing. And this is remote control, which you can see over here. This is a remote where there are different functions: forward, backward, turn left, turn right. For the cleaning purpose, floor cleaning. This is for grass cutting purpose, and this thing over here is for the pump, which will be used over here. And it's like the remote control. So in the future we can use this thing even as a carrier, because however it is remote control. So for handicapped person, for transporting some files or some books from one place to other place in the office, they can sit in one place, and just you move this thing by using just one remote. And here it is like we have used the 1 meter range simple antenna for demo purpose. This is what you can see is the RF transmitter. Here RF receiver, and these all things are working using a relay. This is LCD, just used for the display of the relay on and off. You can show you the model. You can see over here. This is a floor cleaner, what you can see over here. This is an adjustable thing. This thing over here is used for the grass cutting purpose. The blades over here, 1500 RPM blade. And the wheels, the motor which we use for wheels are the DC motors, which are 60 RPM. These are gear motors. The motor which is used for grass cutting is a DC motor, 1500 RPM. And now we have used the solar panel of 10 watt, 1.6 amp and 12 volt. So if you use the panel of a high watt, so what you can do is that you can store more energy in these batteries, and at night time, however, you don't use this machine, usually kept aside. So what you do is just the same power you can use it for the lighting source, like lighting some lights of some one room or 2-3 rooms, and even at night time, like you use the same power for other purpose also. However, the battery will be full, right? And in rain season, you won't get the solar power. So what you do is there is also one more application like AC. You can charge the batteries also through AC supply during rain season and all. If you won't get that much power from the panel. Just I can say that this is eco-friendly and the multi-purpose for indoor and outdoor applications.
I'm Pallavi. I'm from Dr. M. Shetty Institute of Technology, Mudbidri. We have done project about automatic conversion of carbon dioxide to oxygen using MPPT with SPVA. The working of this is all about when the sunlight falls upon the solar panel, it will give this power to the MPPT circuit. In the MPPT circuit, it will convert the voltage to the required level. If the voltage or current is lesser, then it will give to the air purifier circuit. In the air purifier circuit, there are two sensors. These two sensors will sense the carbon dioxide inside the chamber, and it will give it to the microcontroller, and it will be displayed. And if the value is greater than the expected limit, then the high voltage generation will start inside the chamber, and it will convert carbon dioxide to oxygen.
My name is Akash and he is my friend Deepakar, and here is my guide Anguraj sir, and we are from Don Bosco Institute of Technology, and we are doing a project called a novel approach for regulation and management of traffic. The main objective of our project is to count the number of vehicles present on the road and alert the time accordingly for the number of set of vehicles which has been sensed by the particular load cell what we have in here. Deepak? Yeah. So like you can observe here is whenever he gives a pressure on that particular load cell, it takes into account the number of vehicles present over there in the road, and it will allot the seconds in accordance with. So what happens here is the signal is red right now, and he is giving the pressure. I mean, like the vehicles are getting counted and the signal is red here. So like when you switch this particular signal from red to green, it will actually calculate it will calculate inside the microcontroller, and it gives the proper time accordingly. I'll just switch this particular thing to green signal now, and we'll say like the number of two-wheelers were present was 5 and the number of four-wheelers was 4. So like the number of time given is 20 seconds, and the time is going from 20 to 0. The LCD we have used acts as a down counter also. Yeah, 5 and 3. Total number of vehicles is 8, and the seconds given is 22 seconds for the vehicles to pass the green signal. By doing this, we can avoid the road accidents due to red signal jumping. So this was our main idea to concentrate about, and that's what we have done in our project.
Hello, My name is Saurabh Jadhav. I am from KLS Dr. M.S. Sahyadri College of Engineering and Technology. I am the student of Telecommunication Department. We have developed one antenna which is compact of multi-band frequencies. This is the actual design of the antenna. This antenna supports two frequencies like WiMAX and the Wi-Fi frequencies. WiMAX antenna lies in the 3.2 to 3.8 frequency, and the Wi-Fi antenna lies at 5.2 to 5.8 frequency. It supports the IEEE standard 802.11 A/B/G. The main intention behind this antenna, developing this antenna, is whatever existing antennas in market is unable to provide the multiband, the need of multiband frequency. So we have tried to combine two antennas within a single chip. So it reduces the effective cost as well as increases the battery life. How battery life? Because if we are considering the handheld devices like a smartphone or the laptops, the maximum energy or the signals, the battery life is wasted for the searching of the network that's using antenna. If we are using a single particular antenna which can be used for accessing a WiMAX signal and the Wi-Fi signal, the only single battery can be used for that, and battery will be used for more longer. And the main intention is of the developing this antenna is whatever desktop PCs we are present all over the industries as well as the computer laboratories. If you want to make it the wireless LAN, wireless local area network, then we need to install routers, cables, RJ45 cables, etc. But instead of those all, if we inserted such a chip which is available at 80 to 100 rupees, when we are going for the mass production, the cost will be reduced automatically. If we insert such a chip, then it is possible to provide the Wi-Fi facility to the desktop PCs also. And not only Wi-Fi facility, it can access the WiMAX signals also. And this antenna is developed simulated using HFSS software, high frequency simulator. And then we have carried out the PCB, taking out the Gerber file. Then we have developed this PCB, and we are testing it for the antenna. Using cell phones, we can check the signal strength of this antenna also. It's providing the 45% of the signal strength. If compared to the other antennas, it vanishes, and the signal strength or the speed is maintained over the 120 meter. The constant speed can be maintained using this. The range, it won't decrease with the range.
My name is Pankaj Namda. I am from SG Badekar Institute of Technology, Belagavi. Our project aims at economic generation at ground levels. Ground levels in the sense it's on home levels. The project basically needs very low wind energy. It works as an emergency lamp. You can use it as a street lights. On all the basis you can use it. So now whenever we think of wind turbines, there are outside. We use it outside. They are on commercial scale. The per watt generation cost is too high. So in that case, what we do is we try to reduce cost. So we use multiple small turbines. Small turbines are just half watt, 1 watt. For lighting purposes, we may require only 1 watt or 2 watts, and if LEDs are used, then we require only very few watts of it. We require currents in milliamperes. So in that sense, we try to generate power at home levels, which the wind speed required is 1.2 meters to 3 meters per second. So whenever, now for example, when all the people enter a small lab, what we do is first of all we switch on fans. Right. So whenever we switch on fans, the energy from the wind is coming, but the energy is not consumed there. So what we do is, from fans we generate energy here itself. So when the wind turbines rotate, energy is generated. The energy generated is around 2 to 3 watts for 4 turbines. We charge the batteries, and there is a small battery inside it that gets charged. So the small battery inside it is charging because of the motion of the wind turbines. So whenever I take it to the fan speed, here itself, we start rotating. These start rotating. As these are rotating, there is a boost circuit inside it. What we do is, one volt is generated, we boost it to around 3 to 4 volts. DC boost converters, you all know it. So on that basis, we convert it to 5 volts. While doing it, we charge a small battery of 4 volts. This battery can give a backup of around 8 to 10 hours on lighting this LED lamp. That's the main purpose of it. And this project can be implemented even outside for the street lamps like wind speeds. For wind speeds of around 3 to 4 meters per second, we can generate power to light the street lamps.
We are from Canara Engineering College and our project is remote control Arakanat tree climbing mechanism. In southern part of the India, Arakanat cultivation is one of the main agriculture activity. So regular spraying of pesticides and all, one has to climb the tree and do the necessary job. Nowadays you can't find a proper labor in time. So what we did is build a robot, mechanism, which will climb the tree and do the necessary job. We attached 4 motors on 4 corners, so it will open like this, and a tree comes in middle, and there is a attachment mechanism. Each motor will be having a torque of 6 kg, so total there will be 24 kg of lifting capacity. Entire mechanism is controlled by remote control, so a person sitting at the bottom of the tree can control the entire mechanism. This is for spraying, aiming the perfect area of the Arakanat.
This is a power generation project. You might have seen huge structures, wind generators. Those are horizontal axis wind turbines, horizontal axis ones. The height of those towers is limited, right? Up to 80 meters or 100 meters. You cannot go beyond that 80 meters because of its mechanical strength and as well as economic factor. But the wind is more powerful and continuously it is blowing as we go high and high. Altitude increases, right? So we cannot reach using these turbines. So we have a solution here. This is a kite which can reach